Hi and welcome to this Junior Cycle Higher Level Maths revision video. In this revision video, we're going to be revising factorisation. For your Junior Cycle exam, you're required to know 4 different types of factorisation. The first is highest common factor, the second is grouping, the third is factorising quadratic trinomials, and the fourth is difference of two squares. We'll also look at putting them together for multi-step factorisation and also some more complex examples. What's really important to note is that factorising is the backward step of expanding or multiplying out the brackets. So for example, if I gave you 3 bracket 2t plus 3m, we would expand it or multiply it out to get 6t plus 9m. The backward step to this, so working from that 6t plus 9m back to what we started with, that is factorisation. And this particular type of factorisation would be highest common factor. Here's another example. So imagine if I started with 20y plus 8p. So I've already expanded the bracket. So I need to work backwards, factorisation, again, highest common factor. And when I work backwards and get the highest common factor of 4, I write that as 4 bracket 5y plus 2p. Multiplying that bracket back out should get us to 20y plus 8p, and that is expanding. So it's always a good idea, especially when you're getting started with factorisation, to double check your work by expanding out, multiplying out those brackets. There are 2 different forms that we talk about. So the first is factored form, and then we have expanded form. So factored form is when it's written with any kind of brackets. Okay, there may be 1 set of brackets, there may be 2 sets of brackets, maybe there's 3 sets of brackets. That is factored form. So we're writing them as factors. Expanded form is where there's no brackets because everything has been multiplied out. So in both of these examples, our factored form is on the left and our expanded form is on the right. Factorisation type 1, highest common factor. So when we're attempting this type of factorisation, we're asking ourselves the question, what is the highest common factor in both terms? i.e., what is the biggest number that divides evenly into both terms? Remember that a letter is standing for a number, so it can be a common letter as well. We're going to start with binomials, so where there are 2 terms, but this can be applied to more than 2 terms. So when we talk about the HCF, we're talking highest common factor. It is taken out, which is another way to say divided, and we end up with a bracket. And if we've started with 2 terms, we should end with 2 terms in our bracket. So let's look at an example. Factorise the following. We have 3 questions here. The first part, 6x plus 10y, has already given us the highest common factor of 2. So if we divide 2 into 6x, we get 3x. And don't forget, you also need to divide your 2 into the second term, which is 10y, leaving us with 5y. At this point, while we're starting out, if you want to double check by multiplying back out, 2 by 3x gives me 6x and 2 by 5y gives me plus 10y, which is what we started with. Now, you can always do this quickly in your head just to double check, but at the moment, it's definitely something I would suggest that you get used to doing until you're more familiar with your factorisation. In the second part of this example, we haven't been given what's common. So we need to figure out what number divides into 6x and 9y. And the answer is 3. So when we divide 3 into 6x, we get 2x. And 3 divides into 9y, 3y times. That's our answer. We can just do a quick double check to make sure we're okay. This is 6x plus 9y, which is what we started with. Now, up to this point, we've had no letters in common, but that changes when we get to the third part. The third part is 6p squared minus 12pq. Now, as you're starting out, what I find very helpful is to write any squared as pp. So p squared means p by itself, which is p multiplied by p. Remember, when we're multiplying letters, we just need to write them side by side. So here, minus 12pq means p multiplied by q. The reason I suggest writing it out like this to start is it's easier to see it. So the first thing we'll ask is what number divides into 6 and 12? And the answer is 6. Then we see, are there any letters that are common to both terms? And there is a P. What I like to do with the letters is simply cross them off to show that they're used. Then when I go to write what's in the bracket, I look at my 6p squared, but I focus on the number. So 6 divided by 6 is 1. You don't have to write the 1. You can write the 1. That's absolutely fine. And there's a letter P left, a P that we didn't cross off. Minus 12 divided by 6 gives me 2. And then there's a Q left. Now, just again, if you want to do a quick double check, we have 6p by 1p, or that could just be p if you prefer. That's 6p squared, and 6p by minus 2q, we would multiply the numbers first, which will give us 12, and then we'd write the letters in alphabetical order. So minus 12pq, which is what we started with. Factorization type 2, grouping. So when we ask the question, what is the highest common factor of all terms, sometimes there actually be no highest common factor. So there will be no number that will divide in evenly to all terms. There will be no letter that is common to all terms. So in that case, what we want to do is to split the terms into groups where there is a common factor. For grouping, it really only makes sense if we have 4 or more terms. At junior cycle, you're really only going to see 4 terms. So first step, group the terms that have common factors. Second, we take out the highest common factor from each group. Step 3, we want to then take out the highest common factor, i.e. the bracket, from both terms. So this will make more sense as we're doing it. Let's look at example 2. There are 3 parts. First thing we want to do is we want to check, is there anything common to all terms? And unfortunately, there is not. So what we're going to do, we're going to split them into 2 groups. In each of those groups, there is something in common. In the first group, there is a P common, leaving us with x plus y. In the second group, there is a Q common, leaving us with x plus y. The brackets are the same, so they are common. So I pull that out in front, and that leaves me with a P plus Q. I then have an AX plus AY plus 7x plus 7y. Again, if I can, I'm going to group them as they are. An A is common, leaving us with x plus y. In the second group, a 7 is common, leaving us with x plus y. X plus y is common, and the second bracket is then a plus 7. In the third part, again, we group them as they are. M is common, leaving us with an or minus s, plus n is common, again leaving us with an or minus s. Or minus s is common, times m plus n. The grouping questions can get quite challenging, especially at higher level. So let's look at 2 higher level examples where we'll be required to rearrange the terms so that there is something in common. And we also have to be very, very careful about our signs. So our first part here is AC minus BD minus AD plus BC. So there is nothing common to all 4 terms, and unfortunately we can't even group them as they are. So what I'm going to do is I'm going to swap these 2 terms. So I have AC minus AD minus BD plus BC. So now that there is something in common. There is a few different ways you can rearrange them. All ways should end up with the same answer. In my first group, A is common, leaving us with the C minus D. Now, this will link to when we work with the guide number method, but I will always take the sign of my third term and just check to make sure it's okay. When we deal with quadratics, this method will always work. When we're dealing with our grouping, we'll just have to double check. So B is common. That leaves me with a D and then minus C. So when I check my brackets are not the same because C take away D is not the same as D take away C. So what's wrong is, in my first bracket, C is positive, but in my second bracket, C is negative. In my first bracket, D is negative. In my second bracket, D is positive. So my signs are wrong. So what I'll do to fix that is I change my sign here to a plus, which will change this to a minus, which will change this to a plus. So now I have minus D plus C, which although is written the wrong way around, is actually the same as the first bracket. So now I have C minus D and A plus B. If you rearrange it differently, you may not run into that issue there with signs. So let's look at the last part here. X squared minus 2y minus 2x plus xy. Again, we need to do a little bit of rearranging to make sure that there is something in common. So I'm going to again swap my two middle terms and I get x squared minus 2x minus 2y plus xy. In my first group, there is an x in common, leaving me with x minus 2. I'm always going to bring down my third sign and then just check if it's correct and change it if needs be. Y is common. That leaves me with 2 minus x. Now, this might be a little easier to see given we've done the last one. Unfortunately, the brackets are not the same. The signs are incorrect. So I'm going to change this to a plus, which will change this to a minus, which will change this to a plus. Now my x is positive in both brackets. My 2 is negative in both brackets, which now means they're the same. I now have an x minus 2 and an x plus y. So now let's talk about quadratics. The name quadratic comes from quad, which means square, because when we have a quadratic, we have the variable squared, so like an x squared. This is also said to have degree 2 because of the power 2 on the x. I think it's important that we understand what the graph of quadratics look like, and these are the two different graphs that we can get. The graph on the left is a positive quadratic and the graph on the right is a negative quadratic. And a great way to remember this is by saying positive people smile, negative people frown. So let's talk about factorization type 3, which is about quadratic trinomials. So quadratic means x squared, trinomial means 3 pieces. So a quadratic trinomial will look something like this. Ax squared plus bx plus c. So it'll have an x squared term, an x term, and then a constant. That's a number on its own. We're going to deal with a, b, and c being integers, so they are positive and negative whole numbers. We don't have to worry about fractions for the moment. So quadratic trinomials, the method we're going to use here is called guide number. And I love guide number because it doesn't take a huge amount of thinking. The alternative to this is trial and error, which is very, very hard to do when the numbers get bigger. So what we're going to look at is basically a special case of grouping, so factorization type 2. So think of this, we started with highest common factor, we then moved on to grouping. Grouping was using our highest common factor. We're now on factorization type 3, quadratic trinomials, and this factorization will be using the grouping we've already learned. So I'm going to show you the expanding of the brackets before we do the factorization. Remember, expanding is backwards factorization, or factorization is backwards expanding. So I have two brackets here. It is x plus 5 by x plus 2. Now to multiply those out, we'll split the brackets and multiply. So we get x squared plus 2x plus 5x plus 10. However, we're not going to stay with those 4 terms because we have like terms there in the middle, 2x and 5x. So we're going to combine them to be 7x. So although we had 4 terms, they simplified to 3 terms, and our answer is what we would call a quadratic trinomial. So 3 pieces. It has an x squared, an x, and a constant. Now, let's actually work through the factorization of this. So we've just done it the other way. Let's look at the factorization. Remember, this is guide number. So the first thing we're going to do is to get the guide number of the quadratic. The guide number is the first coefficient, so the coefficient of x squared, which actually we don't have. But remember, if we have an x squared, I have 1x squared. We just have been too lazy to put in the 1. So we multiply the first coefficient, the coefficient of the x squared, which is known as a, by the last term, which is the c, the constant, and we multiply those together, which will give me the guide number. So I'm going to do this over here. GN stands for guide number. We have 1 by plus 10, which is plus 10. So the guide number of this is plus 10. If there was a negative in there, just be very, very careful. So now step 2, find the factors of your guide number that add to give you b. So remember, b is the number in the middle. So I'm looking for factors of 10 that add to give me the coefficient of x. So that add to give me 7. So we can list out all the factors. So it could be 10 and 1 or 2 and 5. They're both going to be pluses. So then we have to figure out, well, which one is correct. Well, plus 10 plus 1 gives me plus 11, which is not what I want. But plus 2 and plus 5 give me plus 7, which is what I want. So now that we've figured those out, we're going to rewrite the quadratic, replacing b with the factors we've just worked out. So what happens is that 7x is going to be split. So we get x squared plus 2x plus 5x, which is still 7x. So I've just made it look different. I haven't changed what it's worth. So this is the same as going in with a €5 note and coming back with 2 2s and a 1. It's the same value. It looks different, but it is the same value. Where we got that 2 and the 5 was from our guide number, okay? And that's so important. It can't be any 2 numbers. We have to work with our guide number first. Now that I have 4 terms, I'm going to use grouping because I couldn't use grouping when there was 3 terms. It wouldn't make sense to group 3 terms because I'd have them grouped as is, which doesn't make sense, or in 2 and 1, and actually is one thing on its own a group. So what we've done now is we have allowed this to be 2 groups of 2 terms. Now, in this method, you will never have to rearrange. That's the good news. It's a little bit easier than just our grouping questions. So the first 2 terms, what is common? X is common, leaving me with an x plus 2. Another thing that's really nice about using guide number is this third term, the sign will always come from the third term. So I'm going to have a plus because it's a plus 5x. 5 is common, which leaves me with an x plus 2. And I double check that my brackets are the same, which they are, and then I combine. I like to do the x plus 2 first, and then have x plus 5. But remember, multiplication is commutative. What that means is it doesn't matter what order you multiply it in. 2 by 3 is still the same as 3 by 2. So that's my answer using our guide number method. So let's look at another one to see how we go. This time we just have to be a little bit careful because our guide number, remember, first and last, so it's the coefficient of our x squared, which is 1, and then our last is minus 3, so the guide number is minus 3. Because it's minus and we're looking for the factors, we're going to have different signs because I'm looking for 2 things that multiplied to give me minus 3. So just be careful with your signs. So 3 is prime. So it was either minus 3 by plus 1 or plus 3 by minus 1. Now, I want it to add to my b, the coefficient of my middle term. So it has to add to 2. So the correct factor pair for us will be a plus 3 minus 1. Because if we used minus 3 plus 1, it would have been a minus 2. So I have x squared. Now remember, I'm splitting this into two pieces so I can do grouping. Plus 3x minus 1x, or just minus x, minus 3. Now, if you did that in a different order, your sum will look a bit different, but our final answers will be the same. So I am going to work with our groups as is. First group, x is common, leaving me with x plus 3. Remember, this sign will always follow the sign of the third term. There looks like there's nothing common, but actually 1 is always common. So we'll pull out a negative 1. Just mind your signs. That leaves me with an x. Now, minus 3 divided by minus 1 gives me a plus 3. Just double check if you need to about multiplying that back out. Our brackets should be the same. They are. And we have x plus 3 times x minus 1. Now, if you are very eagle-eyed, you might have noticed something, and you might be questioning this long method. So I'm going to address that. If you haven't noticed, that's fine. So I'm going to talk about a shortcut to factorising quadratic expressions. So this is a shortcut that I still will think of in terms of guide number. There is, like I keep saying, a different method, which is trial and error. It's similar, the shortcut here will be similar to that, but trial and error is a different method. So this is like a shortcut if we're using guide number. There is only one issue. It can only be used when the leading coefficient is 1. So that is where it's just an x squared. So leading coefficient is the coefficient of the x squared, and that has to be 1. So when it looks like x squared, just x squared, then we can use this shortcut. Maybe you already noticed the shortcut. So this is the same example, but I'm going to do it as a shortcut. So first thing I'm going to do, just like the last go, is get my guide number, which is minus 3. I'm then going to find my factors. We had plus 3 minus 1, minus 3 plus 1. I'm still focusing in on this plus 2. So I want the factors that give me a plus 2. So I'm going to have plus 3 minus 1. Now, this is where the shortcut kicks in. We can go straight to our brackets here, because in our brackets, and maybe you noticed, they both start with an x, that's coming from the x squared, and then the factors that we worked out here can go straight into our brackets like that. So if you noticed that on the last two examples, well done, eagle eyes. If you didn't, this is an option. Some students prefer to always use the longer method because they won't get confused. That's absolutely perfect, but it is nice to know that we can use the shortcut in some cases. Now, here's an example of the guide number method where we cannot use the shortcut. And the reason we cannot use the shortcut is it's not just an x squared at the start, it's a 5x squared. So that means that the shortcut will not work. And I'm going to do this out using guide number, and you'll see that the answer doesn't work out the same way. So first thing is my guide number. My guide number is going to be the first coefficient. Oh, there's meant to be a highlighter. Let's see. Yeah, first coefficient by my last term. So that is a plus 10. Now, plus means they're going to have the same signs. And when I say them, the factors, because factors are things that multiply to give us plus 10. So we're going to have the same signs here. I want to add to get at minus 7. So they're both going to be negatives. So I have 10 and 1 minus a minus, or 5 and 2, and that's it. And the correct one for me is minus 5 minus 2. So then I'm going to come along, split out that minus 7x as a minus 5x minus 2x, and then I'm going to do my usual grouping. Again, if it goes in a different order, it'll look different in this step, but final answer will be the same. 5x is common, leaving me with an x minus 1. Then remember, this sign always follows the third term, so it's minus. 2 is common, leaving me with x plus 2 divided by minus 2 is minus 1. Do a little multiplication back in your head if you want to double check. Minus 2 by x minus 2x. Minus 2 by minus 1 plus 2. Yeah, that looks good. Double check your brackets are the same. They are. That gives me x minus 1, 5x minus 2. Now, you can see that it's not as simple as x minus 5 and x minus 2, but using the shortcut. So that shortcut will not work in this case, and the reason is because the leading coefficient, i.e. the coefficient in front of the x squared, it is not 1. So there is 5 there. So let's look at another example with regards just a more complex one. We have a leading coefficient, so can't use the shortcut, and we have a minus 4, which means that sign of the guide number will be negative, which causes a little bit more problems. They like to include these because these are the ones that students have to think a bit deeper about and often go wrong with their signs. So my guide number here is 3 by minus 4, so minus 12. So minus means I'm going to have different signs, and that makes it a little bit harder because for every factor pair, the signs could go either way. So I like to do this list of factors quite systematically, and what I mean by that is I work in a method that I won't forget any. So I like to start with 12 and 1. So maybe it's a plus 12 minus 1. Maybe it's a minus 12 plus 1. And then I'll try 2. So plus 6 minus 2, minus 6 plus 2. 3. So maybe it's a plus 4 minus 3 or a minus 4 plus 3. After 3, 4, which we've already included. So now I have every option available. You can also do the adding here. So plus 12 minus 1 is plus 11. Minus 12 plus 1 is minus 11. You'll get the same answer, just with a different sign. 6 minus 2 is plus 4. Minus 6 plus 2 is minus 4. Plus 4 minus 3 is plus 1. And minus 4 plus 3 is minus 1. Now, you don't have to do all this. When you get good, you'll often just figure it out in your head, and that's fine. But a lot of times students like to be able to work through this when they're starting. So we want this to add to give me the coefficient of the middle term. And there's no coefficient, but remember I have an x, which means I have 1x. So I want that to add to plus 1. So the correct factor pair for this question is plus 4 minus 3. So I have 3x squared plus 4x minus 3x minus 4. I'm now going to do some grouping. I have an x common here, leaving me with 3x plus 4. Remember, we always pull down the sign of the third, which is minus. There seems to be nothing in common here, but remember, even when there's nothing in common, a 1 still divides into both, and we're left with 3x plus 4. Double check your brackets are the same, they are, and then we have 3x plus 4 times x minus 1. So just be careful when you have a negative guide number. The fact that the factors will have different signs, it does add an extra layer of complication in there, and it's easy to come up with maybe the 1 but with the wrong sign. So before we do our last type of factorization, I just want to revisit square numbers or perfect squares. So square numbers are numbers we get by multiplying a number by itself. So for example, 1 squared is 1 by 1, 2 squared, 2 by 2, 3 squared, 3 by 3, and so on. You should really know up to 12 from your tables. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 11 11s, 121, and 12 12s, 144. If you want to go one further, 13 13s, 169. So why are they called square numbers? Well, these numbers represent the area of a square with a given side. So for example, 9 is the area of a square with sides 3. So 3 by 3 gives you 9. So we can see them visually here as squares. So our last type of factorization, factorization type 4, is difference of two squares. Unlike the other three types of factorization, this is quite a standalone type of factorization. I personally think it's the easiest, but we're going to work through it and see where it comes from. So it's called the difference of two squares because difference comes from the word subtract. So when we talk about the difference in maths, we mean subtracting, and two squares mean two square numbers. So let's start like we did the last time with two brackets and expand it. So we're going not through factorization, but through expanding, which remember is the opposite of factorization. So to multiply out these two brackets, we'll split the bracket and multiply out. This is very similar to what we did for the quadratic trinomial example. However, something interesting happens. When we add our like terms, they cancel out. They give us 0 because we have a minus 5x and a plus 5x. So if we take a deeper look at this example, the two brackets that we started with were actually the same two numbers, just one had a plus in the middle and the other had a minus in the middle. And because of that plus and minus, the 5x and the minus 5x in that middle, they had opposite signs, which gave us 0. This means that when we got our answer, we do get a quadratic. Okay, this is a quadratic. X squared minus 25 is a quadratic. Because remember, quadratic means it has an x squared. It's not a quadratic trinomial. It doesn't have 3 pieces, but it is a quadratic. It is a special type of quadratic. So notice how we didn't end up with 3 terms, we ended up with 2, and this is called difference of two squares. My two answers, x squared, 25, both of them are square numbers, and it's difference because there is a minus in between. Okay, so let's actually work through this as an example working the other way. So x squared minus 25. The first thing we're going to do is we're going to find the square root of both of those numbers. So if you haven't come across this before, square root looks like this. And it asks the question, what number multiplied by itself gives us 25? It is usually beside or very close to your squared button on your calculator. When you put that in, you'll get 5. The square root actually means the positive square root, and we'll talk about that a little bit more when we're looking at surds. So what squared gives me x squared? That's straightforward because it is simply x squared. And then 25 is 5 squared. Now, I know a lot of eager students will go, oh, do I need to do that step? And I am definitely one for working efficiently and not doing any steps that aren't required. However, this is a step that I would strongly encourage everyone to try because this is something that students always forget to actually do the square rooting. It is such a common mistake and the line will literally take you 20 seconds to write down. So do it. We're now going to open two brackets. This looks like this. It looks like our answer for the quadratic trinomials. We're going to fill the brackets in with the numbers we calculated in step 1. So an x goes at the start of each bracket and a 5 goes at the end of each bracket, and then one bracket gets a plus and the other gets a minus. How easy is that? So as long as you remember to square root your number, which is a really common mistake, and don't put 25 in our answer, we get x plus 5, x minus 5. So let's look at a difference of 2 square example. So x squared minus 4y squared. This is a case where students would often forget to square root the 4. So this is actually 2y to be squared. Remember, when we have a squared, it only squares the thing it touches. So 4y squared means 4 times y squared. So the 4 isn't squared. So this is what it ends up looking like. We open our two brackets. We get x and 2y, x and 2y. Plus goes in one bracket, minus goes in the other. For part B, again, remember that number is not squared, so we have to square root it. So 16, the square root of that is 4, x to be squared, minus 25y squared is 5y to be squared. In our brackets, we get 4x, 5y, 4x, 5y, a plus in one and a minus in the other. Now, I've thrown in a challenge here for part C. So if you would like to pause it and try it, do. It is an interesting question. It's probably a little bit beyond what we would need to be able to do for junior cycle higher level. However, there's no difference to what we've been doing before. It looks more complicated. Okay, so hopefully you've had a go at that. So the good news is that first thing is already written as a bracket squared. The second thing, I'm going to write it as 3 squared. A lot of times students try and multiply it out, and actually multiplying it out, we won't be able to factorize it. So you just need to be mindful that we have a difference of 2 squares here. And they told us using the difference of 2 squares factorize this. So now we have 2 brackets squared, and I'm going to follow the same logic, but I'm just going to move down here a little bit just for space. So I open my 2 brackets, and they'll need to be a little bit bigger than usual. I fill in the first bracket at the start, so 3a minus 2b, because that's everything that's in the bracket. I put the second bracket in at the end. So if it helps, I'm going to do a little bit of color. So there's my first bracket. And here's my second bracket, and then I get a plus in one and a minus in the other. So that's our answer. So I'll write it without the highlights so you can see. So you get 3a minus 2b plus 3, 3a minus 2b minus 3. So we don't have to touch the sign in the first bracket. You know, think of this example here, part B. 4x just went in as is. We didn't touch it. We didn't change anything. 5y went in as is. And we put a plus in one and a minus in the other. That's exactly what we were doing for part C. We took what was in that bracket squared and put it at the start. We took what was in the second bracket squared and put it in at the end. I wouldn't be too worried about that, but it's nice to see where this can go. So now let's look at a multi-step factorization question. So when we're doing factorization, it may be the case that more than one type of factorization is required in order to factorize fully. So I'm going to make a little list. Highest common factor is my first one. Grouping is my second one. Third one is quadratic trinomials. We're using guide number. And the fourth is difference of 2 squares. Now, what happens in a lot of cases, students go, oh, it's difference of 2 squares because it has an x squared and it has a minus. But if you actually go to your calculator, is 45 a square number? Is 5 a square number? And the answer is no. And how you know by your calculator is root 45 doesn't give me a nice number answer. It gives me 3 root 5 or 6.708, blah, blah, blah. So difference of 2 squares is not correct. So it's not grouping because it doesn't have 4 terms. It's not a quadratic trinomial because it hasn't got 3 terms. It is not a difference of 2 squares because 45 and 5 aren't squares. So the only thing that's left is highest common factor. And actually, highest common factor is what I would generally suggest that you try first for any question. So is there something common? Yeah, 5 is common, leaving us with 9 minus x squared. Now, interestingly, if we look at what's in this bracket, this could be factorized again. And this could be factorized using difference of 2 squares. So if you looked at this and thought, oh, it's difference of 2 squares, you were onto something. But we couldn't do difference of 2 squares straight away. We had to do highest common factor first. So if we're doing this, what I suggest is don't drop the 5. Keep the 5 there. It's not going anywhere. If you do it or stop writing it down, chances are you'll lose it in the final answer. I'm going to use square brackets. Square brackets mean exactly the same thing as round brackets in our case. The only difference is I will be able to tell the difference between my round brackets and my square brackets. Because remember, if I'm doing difference 2 squares, I want to write 9 as a number squared and x as a number squared. And if I had too many round brackets, visually, I would get confused. You can use round brackets, that's fine. I just think the square brackets make it a bit easier to see. So my next step, I'm ignoring that 5, it just stays in front. I open my 2 brackets, I put 3 at the start, x at the end, plus in one, minus in the other, and then I'm going to get rid of those square brackets because it's 5 by 3 plus x by 3 minus x.